Good morning, students and teachers. Welcome to the session of Leap to Learn, Students Empowerment Workshop. So we'll be starting in few minutes. Yes, good morning. Good morning, students. Again, welcome to Leap to Learn program conducted by Learning Links Foundation in association with Niti Aayog and Adult Innovation Mission, which is sponsored by Dell Technologies. So today we are here to learn new things, how to develop projects, how to bring your ideas to lives, how to use the equipments in ATL labs. So today we are having the sessions like on tinkering fundamentals and industrial revolution. So we will be seeing what are the things, outline of the emerging technologies associated with the fourth industrial revolution, also the basic of electronics, the virtual circuits, components, the breadboards, the circuit designing, as well as some activities. So I think we can start with the session. Also, I want every teachers to post the photos of the students. If the teachers are playing the sessions in the projector in the ATL lab, please take the pictures of the students watching the program and post in our WhatsApp group. As well as I need the list of students, the students' name, their class in a separate column like boys or girls in Excel sheet. This is for issuing their certificates. So teachers, please get ready with those things and share in the WhatsApp group. So I think we can start. Aglesh.
Okay, thank you, sir. Okay, hello everyone. Welcome to this boot camp. Okay, so today we will discuss about the tinkering fundamentals and industrial revolution. Okay, so everyone be ready to learn various things. Okay, like industrial things, and you have to learn basic electronics, basic components of electronics. Okay. Okay, now I'm sharing my screen. Just wait. Okay, so topic is introduction to industrial revolution. Okay, and basic electronics. Okay, so we have to discuss about the introduction to industrial revolution. Next thing we have to brief on fourth industrial revolution. Okay, and next thing we have to discuss about the basic electronic components, and most important we have to basic test and measurement equipment. Like we have to use some virtual platform for making the circuits. Okay, using all the basic components of electronics. Okay, so what is revolution? Okay, I think everyone you have to okay. So introduction to industrial revolution. Okay, I think everyone you have to watch this picture. Okay, so by this picture you have to see this. Okay, so this is the first era. Okay, and then step by step we have to update something. Okay, in our activity, in our culture, in our environment. Okay, and then we have to reach till here. Okay, so a revolution is a disruptive shift in the way people live and the way business functions. Okay, every time the human being and anyone, okay, update their way of thinking, way of life. Okay, and then they will apply all the things, okay, in the business function also, so they will increase the business functionality also. Okay, so the industrial revolution started in 18th 19th centuries. Okay, when the Europeans and Americans became more industrial and urban. Okay, like in the 18th or 19th century, they will explore something towards the industrial things. Okay, the Europeans and American decide to increase the industries. Okay, they set up more industries. Okay, and the fourth industrial revolution is changing the way we live, work, and communicate. It's reshaping education, healthcare, and commerce, almost every aspect of life. Okay, so in the fourth industrial revolution is it's very yeah. So the fourth industrial revolution is very good for everyone. They will understand how to do the communication easily. Okay, and they will change the face of the education industry. Okay, education and healthcare and commerce also. Okay, so with the help of the revolution, this industrial revolution, we have to add some technologies like artificial intelligence, Internet of Things, 3D printing, autonomous vehicles, quantum computing, and genetics are profoundly contributing to the idea of modern industry. Okay, so everyone aware about these things. Like I think this artificial intelligence. Okay, Internet of Things. So with the help of these things, we have to some develop a very automation thing. Okay, like we have to develop the technology. Okay, using this industrial revolution, like we have to automate their home. Okay, we have to automate the security system also. Okay, like we have to use automatic door unlocking system. We have to use a automatic camera. Okay, camera recording. We have to use the 3D printing also. Okay, so with the help of 3D printing also, we have to design we have to think about the product, and then we have to give the shape. Okay, before 3D printing, we are not we are designing the home structure on paper. Okay, but with the help of 3D printing, it is possible to make a prototype of any house, any malls, shopping malls. Okay, using 3D printing. Okay, next thing is introduction to industrial revolution. Okay, I will play this video. Just wait.
Industrial Revolution, 18th to 19th century. The economic developments of the 1800s saw the development of agrarian and handicraft economies in Europe and America transform into industrial urbanized ones. The term to describe this phenomenon would be known as the Industrial Revolution and was first used by French writers but made popular by English economic historian Arnold Toynbee. The Industrial Revolution was underpinned by the Agricultural Revolution. From the mid-18th century to the mid-19th century, agricultural production increased significantly. The huge increase in food output supported the expansion and sustained a large population and boosted trade. The increased use of machines over human or animal power in farming also meant that less farm workers were needed, and they could leave the land to industrial towns. Better metals and richer fuel also contributed to industrialization by creating the steam engine, an integral machine to industrialization which powered factories, locomotives, and ships. The new steam engines used coal and iron, both in their construction and as fuel, increasing demand for these resources. Roads, canals, and railways changed Britain dramatically, connecting Britain and allowing goods to be sent over long distances. Visually, the revolution was clear in the new industrial towns, with smoking factories dominating the skyline. The cities were horrible to live in, overcrowded, dirty, with dangerous conditions in the factories and strict rules and punishments. The Industrial Revolution saw mechanization in factories of the textile industry, which was previously manufactured in the home, creating the term cottage industry. Now, production could be increased on a large scale because of new inventions such as the spinning mule and the power loom. The iron industry developed with Henry Bessemer's inexpensive process for mass-producing steel. Iron and steel were key materials for constructing the tools and machinery, steam engines, and ships needed for the industrial progress. Industrial labor opportunities drew people to the cities from the countryside, to such an extent that in 1750, only 15% of the population of Britain lived in towns. By 1850, over 50% of the entire population of Great Britain lived in either a town or a city, and by 1900, it was 85%. London had 4.5 million people, Glasgow 760,000, Liverpool 685,000, and Manchester and Birmingham 500,000. Great Britain was the birthplace of the Industrial Revolution and was the only mature industrial economy for a long time. Historians have speculated that this was because, as an island, there was relative peace and stability for Britain compared to mainland Europe. Rather than spending on a large defensive standing army, capital could be spent on other ventures, and there was confidence for investors. Native resources were also abundant and readily available for initial technological developments and inventions. Engineers and inventors were also respected and encouraged in British society and were backed by wealthy patrons. A powerful navy and an empire bringing in vast wealth from its colonies also contributed to the catalyst for industrialization before others. Nevertheless, Germany, France, Switzerland, Belgium, and the United States soon emulated Britain's industrial change, and by 1900, Britain would no longer be at the top, with the United States as the world's leading industrial nation in the 20th century.
Subscribe for more history videos.
Okay, so you have to see in the Industrial Revolution. Okay, so this is the step-by-step things. Okay, so you have to start with some basic fundamentals. Okay, basic things we have to do, like making using the very natural things. Okay, and we have to make some components. We have to make some instrument for doing something. Okay, so step by step we have to update the things. Okay, using some industrial things. Okay, we have to use some natural things. Okay, so first thing is mechanization, water power, and steam power. Okay, so we have to use these three things. Okay, and we have to develop something. Okay, like we have to use make the steam engine. We have we have to use the steam power there. Okay, and we have to use the water power, mechanization. Okay, so first we have to use these three things. Okay, and then we have to think about this. We have to develop more ideas, okay, we have to find out some other power solutions. Okay, so we have to do some add some electricity. Okay, we have to some develop the mass product like assembly lines. We have to use the electricity, okay, as a power, and we have to do using these things. We have to do the mass production. Okay, like before the 20th century. Okay, we are not able to doing the mass production of everything. Okay, so first thing we have to step by step we have to change the power source. Okay, like because power source is very important for us. Okay, for starting time we are not able to give the electricity in all the house and all all the industries. Okay, they are using the water power, steam power, mechanization, these things. Okay, but these are limited things. Okay, but after this we have to use the electricity and some more power sources. Okay, so with the help of these things we have to increase the production. Okay, so that by mass production we have to develop our industry also. Okay, so after that we have to think about this we have to do all the things is using the manpower. Okay, only the interruption of manpower. Okay, so but sometimes we are not able to with the help of only for the manpower we are not able to increase all the things. We are not able to done everything. Okay, so we have to add computer and automation. Okay, so with the help of computer and automation there's very good a revolution and very good updation in the industries. Okay, like with the help of computer we are doing most of the things. Okay, we have to take the data. Okay, and we have to find out some ideas, and with the help of automation. Okay, with the help of automation we have to we have to interruption of machines also. Okay, in the industry we have to interact the machinery also. They are based on the automation. Okay, they are we have to connect with the computer and we have to program. Okay, with the help of programming we have to design the machines. Okay, they do something with the help of programming and computer instructions. Okay, so next thing is cyber physical system. Okay, so with the help of this thing, okay, cyber physical system, we have to introduce the IoT, artificial intelligence. Okay, all the things before this we are not able to control our robots or control our machinery using the mobile tablets or any things. Okay, only we have to program something. Okay, for any particular machines. Okay, they perform all the things. Okay, we have to program for obstacle avoidance robot. Okay, like pick and drop robot. Okay, so only we have to give the command for pick and drop robot. Okay, only they are doing a pick and drop, like going somewhere. Okay, and pick one object. Okay, and drop anywhere. Okay, next thing is in the cyber physical system we have to connect our machinery or robot using mobile and via Wi-Fi LAN, or we have to use some other things. Okay, cloud computing. So we have to connect with our device like mobile computer, and we have to control their our this robots. Okay, and machinery. So today's era you have to see this with the help of IoT and all, we have to use the mobile control robots also. Okay, with the help of AI and IoT, we have to do the automation thing. Okay, like using our mobile, we have to shut down our house fan, lights, anything. We have to control using your mobile or any other device. Okay, so this is the industrial revolution step by step. Like first thing we have to use some limited power source, like limited and natural power source. Okay, and then we have to add some electric power. Okay, so then we have to add computer and automation. Okay, and then there's a big revolution. We have to use some cyber physical system. Okay, via this we have to done well all the things well. Okay, so this is the thing. Okay, so Industry 1.0. Okay, so in 1784, near to 1784. Okay, so in this era we have to use some like natural power source. Okay, like mechanization, steam power, and we have to use the like steam. Okay, and wind loom. So various things we have to use. These are the natural power source. Okay, and then 1870 Industry 2.0, we have to increase our industry. Okay, like doing the mass production, we have to increase the assembly line. Okay, so with the help of the manpower, okay, like we have to do all things manually. Okay, like it's everything like in the industry, like automobile industry. Okay, so first thing we have to do via man. Okay, like every time we have to do everything step by step, like put all the things. Okay, and like we have to attach our body like automobile body parts. Okay, so this is the things we have to do the mass, but not mass production, but not very good quantity. Okay, so with the help of mankind, like we have to do all things manually. Okay, we have to use the electrical energy. And next thing is Industry 3.0. Okay, so we have to develop automation. We have to attach the things with the computers and electronics. Okay, so in this era, in like 1969, okay, in the 19s, we have to add the automation. Okay, we have to program via computer all the things, machinery and like robots. Okay, and they will do various things. Okay, I think every you have to see in the automobile industry right now, we have to use the robotic arm. Okay, with the help of robotic arm, we have to pick out something, and we have to drop on the like a base station. Okay, so this is the revolution in 1969, Industry 3.0. Okay, so next thing is Industry 4.0, like cyber physical system, Internet of Things and networks. Okay, so in this things we have to use some like cloud things. Okay, like there is a things Wi-Fi. Okay, and we have to connect all the devices with the help of the connectivity. Okay, and we have to attach our machinery or our robot using mobile, computer, anything. Okay, so any device we have to like this time we have to control our home things. Okay, using mobile, computer, or anything. Okay, any device. So this is the things. Okay, step by step is revolution, like Industry 1.0, 2.0, 3.0, and 4.0. Okay, so this is the thing, industrial revolution. Okay, so this is the fourth industrial revolution. I will show you. Like in this revolution, everyone think about the various things. Okay, like small child and teenagers, boys. Okay, so they understand all the things. Okay, all the concept, and they have developed their ideas, and like we have to develop the design thinking also. They like think about any design, and they develop the design also. Okay, and they have to learn something, and they apply with the practical knowledge. Okay, like they have to learn like what is force and what is like resistance. They have to do the practical also using their concepts. Okay, So this is the revolution. Okay, like we have to learn something and then we have to apply and then we have to create the prototype. Okay, so this is the industrial revolution. Okay, we have to see. At first, like you have to see in this video, like first thing we have to, there's like a less manpower we have to use in the industry. Okay, because like sometimes there is very like have done the accident. Okay, with the like in the industry, some humans are like very much affected by their machinery, and they like a much accident doing in the industries. Okay, so we have to decrease the thing manpower. Okay, using the machinery, and we have to use the automation thing. Okay, like all machinery, they are doing like all the works, like they have to pick and they have to attach all the things and they have to extrude something. Okay, like they have to like boxing the things. Okay, so they have to done everything with the using like automation thing. We have to decrease the manpower and we have to reduce the accident. With the help of productivity, you have to increase the like a job, and we have to develop something. Okay, like with the help of we have to do the mass production. Okay, and we have to develop some more industry, and we have to increase the job things also. Okay, so this is the revolution. Okay, industrial revolution. Using with the help of industrial revolution, we have to increase various things, increase the knowledge, increase the job opportunity. We have to increase the security things. Okay, we have to develop various things in the using these things. Okay, and in the industrial revolution. And we have to find out some other like power sources. Okay, so power source and energy source, we have to develop think about this thing, and we have to use, like we have to use the solar power. Okay, wind power. So we have to use these powers, and we have to develop some more things also. Okay, in the revolution. Okay, now we have to learn about the basic electronics. Okay, so first thing we have to see this thing. Okay, basic electronics. What is electronics? Okay, so in the simple term, we have to see this. Okay, electronics is about transforming information into electrical signals and using the high speed processing capabilities of electronics to perform tasks reliably, repeatedly, and fast. Okay, like electronic components and printed circuit boards form the basic part of an electronic system. Okay, so basically, what is electronics? We have to use some electrical signal. Okay, we have to use some high speed processing capability of electronics to perform tasks reliably. Okay, like we have to use the electronic devices. Okay, we have to use the various electronic components. Okay, and in the form of, we have to use the electrical signal. Okay, we have to use some PCB. Okay, we have to use some other small components. Okay, so this is called electronics. Okay, while electronic components process information in the form of electrical signal. Okay, like electronic components, they will process their information. Like if you they electronics components, you have to use some signals. Okay, via these signals, we have to use these signals. We have to develop some circuits. Okay, so we have to use some printed circuit board, or we have to use some breadboards or something. Okay, using these things, we have to create the circuit, electronic circuit, and we have to make the full circuitry. Okay, like we have to mount all the circuits, like we have to use resistor, capacitor, diodes, all the things. Okay, I think everyone have to heard about these things. Okay, so we have to mount all these components on a single PCB, breadboard, or anything. Okay, we have to use the soldering thing. Without soldering, it is it's a prototype circuit. Okay, on the breadboard we have to make the prototype circuit. Okay, using these things, we are able to make the circuit. Okay, and after that we have to make our circuit in the PCB board. Okay, on the printed circuit board we have to design all the mount all the circuits. Okay, and make the circuit. Okay, for the for using this solder thing. Okay, there are many ways to classify different type of electronic components, but the most common way is to classify them in the three types. Okay, like active electronics components, passive electronic components. They are like very basic components. Okay, so we have to see. So first thing is active electronic components. Okay, and active component is a device that acts as a source of energy. Okay, so it's clear about this line. Okay, like this component is like this device is act as a source of energy. Okay, like we have to attach something. Okay, via this component. Okay, and they provide the energy like battery. Okay, active electronic component can control the flow of electron through them. Okay, some of the commonly used active components are transistors, semiconductor, IC, power source. Okay, like battery, AC and DC power supply, etc. Okay, so we have to see here the active components are that component they provide the power. Okay, like they are the basic power source of to transfer electrical energy. Okay, in any device or any thing. Okay, like we have to use electronic particles. Like electron is a negative charged particle. Okay, we have to use the electrons. Okay, so this is the power. Okay, this is the like electron is a power we have to use. Okay, and then we have to transfer the power in any device. Okay, so this is all the power sources are called like active electronics components. Okay, so first thing is we have to use the transistor. Okay, so in a simple term, what we have to do, transistor is a device that regulates current or voltage flow and act as a switch or gate for electronic signal. Okay, so basically transistor is working as a switch also. Okay, like we have to switch on. So it's we have to increase the flow of current. Okay, if we have to switch off, okay, we have to cut all the power thing. Okay, power circuitry. So this is the device they are using for the regulate the current and voltage. Okay, that is called transistor. Okay, I think everyone you have to see in your ATL lab. Go to in your ATL lab and find out the transistor. Okay, for ask about the transistor to your from your ATL in charge or your teacher. Okay, so what is transistor, and please show me the transistor. Okay, so this is the thing. Next thing is semiconductor or diode. Okay, so semiconductor is it's a substance or like it's a property. Okay, like the property of the semiconductor is lie between conductor and inductor. Like conductor is the things like they they are like with the help of conductor we have to the flow of current, we have to continue the flow of current in the circuit. Okay, so this is like conductor, and inductor is not able to increase the flow of current or able to flow of current in the circuitry. Okay, so the conductivity lie between the conductor and like insulator or inductor. Okay, so next thing is diode. So what is diode? Diode is like it's a two-terminal device. Like it's it will restrict the current, okay, like going in the single direction, okay. So we have to use the diodes, okay. IC is an integrated circuit. We have to make some circuitry, like we have to use some IC, okay, and mount all the components on the IC, and we have to make the circuit, okay. And then we have to use the power source like battery, AC and DC power supplies like alternate current and direct current, okay. So these are the active electronic components. Next thing is passive electronic components, okay. So what is passive electronic components? We have to learn about the active components, okay. So for in the active components, they provide the power supply, okay. They provide the power, okay. And what is the passive components? That cannot control the flow of current through them, okay. They cannot introduce energy. They all doing, they the active component, they are doing these things like provide the flow of current, okay, and they introduce energy into the circuit, but can increase or decrease voltage and current, okay. Like passive component, these components don't depend on the energy source for their operation, okay. These are the two terminal device: resistor, capacitor, inductors, and transformers, okay. So we have to, in the next thing, we have to learn about all the things: what is resistor, what is capacitor, what is inductor, and what is transformers, okay. So I think everyone, you have to aware about the resistor, okay. So we have to use the resistor I think everyone, you have to I will give you one example, okay. When we have to see in our washroom or anywhere, okay, we have to attach one pipe with the tap, okay. And when we have to open the water tap, okay, it will flow of the water is going in the pipe, okay, it's going on, okay. So when we have to slow down the tap, okay, and we have to decrease the flow of water, okay. When we have to open the tap, okay, water flowing very forcefully through the pipe, okay. So this is called current, okay. When we have to put the our legs on the pipe, okay, the flow of the water will decrease, okay. So this is called resistor, okay. So resistor is a passive two-terminal component, okay, that implement its electrical resistance as a circuit element, okay. Like it reduce the current, okay, the flow of current, okay. Just like we have to decrease the flow of water in the pipe, okay. So this is called resistor, okay. You have to learn very deeply about the resistor in the next session, okay. And what is sorry, what is capacitor, okay. Like a capacitor is a device that stores electrical energy, okay. Like we have one example, okay. So when we have our phone get discharged, okay, so we have to find out our charger, okay. Like please give me my charger, I will charge my mobile, okay. So what is this? Why we have to attach some wire in our mobile, okay, in your mobile? So what is the basic thing, okay? So when we have to attach our adapter and this USB cable with give the connect via the power source, okay, and this USB cable we have to attach on in our mobile, okay. So the electrons are moving in this USB cable like to power electricity, okay, and then we have to attach our power cable with the mobile. So all the power sources power up this mobile, okay. So we have some capacitor, okay. So capacitor store this energy, okay. First thing, we have to store the energy in our using this USB cable. We have to provide the power and charges to the capacitor, okay. So this is called capacitor, and capacitor is a device that stores electrical energy in an electrical field, okay. So this is called capacitor, okay. So first thing is resistor. Resistor restrict the flow of current. Okay. And next thing is capacitor. Capacitor store the charge. Okay. Next thing is what is inductors. Okay. So I think everyone, you have to see this one. This is the inductor. Okay. This is the resistor. This is the capacitor. I think everyone, you have to see in your remote also. Okay. This capacitor. Okay. And this is inductor coil. Okay. Why we have to see this as a as a coil? Okay. Because if you have see this, okay. So some filament is binding up on this device. Okay. So that's why we have to tell this component is as a coil. Okay. So an inductor is a coil or choke or reactor also. Okay. It is a passive two terminal electrical component that store energy in a magnetic field. Okay. When electrical current flow through it. Okay. When we have to provide the electrical energy. Okay. And we have to like a flow. We have to increase the flow of current through the this coil. Okay. So we have to like store the we have to store we have to develop the like magnetic field. Okay. So that's why we have to say that this electrical component that store energy in a magnetic field. Okay. It's like we have to provide the electrical energy it's the flow of with the help of flow of current. We have to produce the magnetic field. Okay. So this is called inductor. Okay. So what is the difference between capacitor and inductor? Okay. Capacitor it's stored the energy as an electrical form. Okay. And inductor stores the energy as a form of magnetic field. Okay. This is the very basic difference between capacitor and inductor. Capacitor stores the energy in the form of electrical energy. Okay. And inductor stores the energy in the form of magnetic energy. Okay. Magnetic field. So don't confuse in between the capacitor and inductor. Okay. So sorry. Next thing is transformer. I think most of the person you have to heard about the transformer. Okay, I think everyone you have to see in your roadside or in the powerhouse. Okay, so you have to see the transformer. Okay, so in the basic term, what we have to see a transformer is a device that transfers electrical energy from one AC circuit to one or more other circuits. Okay, if you want to provide energy to other in houses. Okay, so first thing what we have to do, we have to take one transformer. Okay, and using this transformer, okay, we have to use the AC circuit. Okay, with this AC circuit, we have to transfer some electrical energy to other person or any other. We have to provide some energy in the other houses. Okay, so using this thing, we have to transfer electrical energy. Okay, this electrical energy to other sources or other circuit. We have to provide the electrical energy. Okay, using the transformer. When it comes to designing electronic circuit, testing and measuring various parameters like current, voltage, frequency, resistance, capacitance, etc. Okay, like we have to use some basic test and measurement equipment, like it is very important. Okay, so hence the test and measurement equipment like oscilloscopes, multimeters, logic analyzer, function generators or signal generator are often used regularly. Okay, using these components, we have to find out, measure and test their components. Okay, like components, we have to test the resistance. We have to find out the current, find out the voltage. Okay, and find out the resistivity. Okay, so these things we have to measure using some measurement equipment like oscilloscope, multimeter, logic analyzer, function generator, or anything. Okay, so first thing is oscilloscope. Okay, so the most reliable test equipment for observing continuously varying signal is an oscilloscope. With the help of an oscilloscope, we can observe the changes in an electrical signal like voltage over time. Okay. So I think most of the persons here, we have to see this oscilloscope in your ATL lab. Okay. If you have to go to the ATL lab after the session or after your school timing. Okay. You have to ask your ATL sir. Okay, so you can please show me the oscilloscope and tell me the all the things and provide the training. Okay, so what we have to see, oscilloscope, like it's things. Okay, we have to find out some signals. Okay, varying signal. Okay, like if you have to watch the oscilloscope, you have to find some discrete and like analog circuits. Like we have to see some sinusoidal waves also. Okay, like an oscilloscope is called also like oscillograph. Okay, non we have to known as a CRO also, like cathode ray oscilloscope. We have to use these things there also. Okay, so this is called oscilloscope. Sorry. Like with the help of oscilloscope, we have to see some varying signal like voltage, usually as we have to plot some two-dimensional graphs. Okay, these things. Okay, using the oscilloscope. So it's a very general purpose instruments. Okay, we have to use in the lab work. Okay, we have to find out some waves. Okay, sinusoidal waves, or we have to find out some signals. Okay, we have to see the variation in the current. We have to see in the variation in voltage also. Okay, so we have to use the oscilloscope. Next thing is multimeter. Okay, so I think this thing also everyone you have to watch in this during the we have to mounting the components on your circuit. Okay, so everyone you have to use the multimeter also. Okay, so a multimeter is a measuring instrument that can measure multiple electrical properties. Like we have to measure the voltage, we have to measure resistance, we have to measure the current. Okay, so in this case we have to it's also known as volt ohm meter multimeter. Okay, it is also called volt ohm multimeter. Why? Because the unit of voltage is volt, the unit of resistor is ohm. Okay, so that's why we have to see the this multimeter is also called volt ohm multimeter. Okay, like it's the unit equipped with like voltmeter, ammeter. Ammeter is a unit of current also. Okay, and ohm meter functionally. Okay, so this is called multimeter. A multimeter is a combination of voltmeter, ammeter, and ohm meter. They provide an easy way to measure different parameters of an electronic circuit like current, voltage, etc. Okay. Multimeter also can measure values in both AC and DC. Okay, like earlier multimeters are analog and consist of pointing needles. Okay, like modern multimeters are digital and are often called as digital multimeter. Okay, like before the digital multimeter, we have to see when we have to rotate the button. Okay, and find out the variation of current. Like we have to find out some measure the parameter like current or voltage. We have to only find out some needle. Okay, needle point out the value or something. Okay, but nowadays we have to use digital multimeter. Okay, only we have to provide in the all the things in the digits. Okay, so this is called multimeter. Sorry. Okay, Tinkercad. Just wait, I will tell you what is Tinkercad. Okay, so Tinkercad, what is this? Like we have to make anything. Okay, like we have to design any circuitry. Okay, using this Tinkercad. Okay, with the help of Tinkercad, we have to make a prototype. Like I in the first starting time, I told you we have to make one prototype circuit, okay, using the Tinkercad, okay, and you have some components, okay, and all the instruments for the related to basic electronics like Arduino, resistor, capacitor, inductor, everything, okay. So I will show you how to log in with your Tinkercad and how to use the Tinkercad, okay. Just wait. Okay. So first thing what we have to do, you have to put the Tinkercad in your browser. Okay, you have to see here tinkercad.com. I will send you this link in the chat box also. Okay, so what you have to do, you have to type here tinkercad.com, okay, and you have to find this page. Okay, so after that, what we have to do, you have to click on the sign in option or here, okay, or join now, or you have to click on the sign in, or you have to find here, okay, the thing is start tinkering. Don't click on join your class, okay. Anyone don't, you have to click on the join your class. You have to click on only the start tinkering, okay. You have to click here and you have to find this page, okay. In this page you have to find the option this sign in option, you have to find this one, okay. So you have to click here, okay, and then after that this thing you have to if you have any your Gmail account, or you have to your own personal account, you have to log in by this, okay. So you have to see here, this is the option, okay, start tinkering, or you have to click on the sign in option, okay. So you have to see here or personal account, okay. If you have your personal account, like if you have Autodesk account, you have to log in via here, okay. You have, if you have any Apple ID, you have to sign via here, okay. But everyone, you have to must log in with your Google ID, okay. You have to click here and you have to put your Gmail ID and password, and you have to log in on your Tinkercad ID, okay. So this is the Tinkercad, okay. With the help of this Tinkercad, we have to make the circuit also. We have to design 3D designing also. We have to do the code blocks also, okay. So various thing is we have to use in this AutoCAD Tinkercad, okay. So everyone, you have to today this is your task, okay. Everyone, you have to open the tinkercad.com, okay, and you have to go to the circuits, okay, and click on the start new circuit, okay. For making some new circuits, okay, you have to click on the create new circuits, okay. Yes, so this is the platform where you have to design our circuit, okay. So this is Tinkercad, okay. You have to see this platform is totally blank, okay, but you have to see here, okay. These are the components we have to use for designing any circuit, okay, like resistor, we have to use the LED, we have to use the potentiometer, we have to use the push button also, we have to use the slider switch, okay, and coin cell, 9-volt battery, breadboards, everything we have to use for making our circuits, okay. So you have to see we have to see the ultrasonic sensor also, we have motion sensor, temperature sensor, okay, everything you have to see here, multimeter also, okay. So today we have to make one basic circuit, like using the push button, we have to blow your LED light, okay. So first thing what we have to use, okay, so first thing we have to collect our all the components, okay. So here you have to see there, you have to see this if you want to change your project name also, so you have to click here, okay, and we have to change the name also, LED LED blinking. Okay, so you have to save the project as LED blinking. Okay, you have to use the code block also here. Okay, you have to see here. This is the code thing. Okay, code part, and you have to see here like start simulation. After making the circuits, you have to click on the start simulation. Okay, and you have to watch your what the result of your circuit. Okay, and you have to see here various components here like basic Arduino, microbit components, circuit assemblies. So we have to see here all the components. Okay. So for making the our circuit today, we have to first thing we have to select our breadboard. So you have to click here, okay, and drag your mouse here and take this breadboard here. Okay. So this is your breadboard. If you want to rotate this breadboard, you have to select this breadboard. Okay, and here you have to see the rotate option. Okay, the left upper corner you have to see this option. You have to click here. You have to rotate our breadboard. If you want to delete this component, you have to just select this component and you have to click here to delete something. Okay, again we have to take the breadboard here and I want to rotate this one like this. Okay, so this is your breadboard, small breadboard. Okay, we have some various breadboards like mini breadboard, small breadboard, and we have to some large breadboard also. Okay, it's a big size. If you want to make like a very big circuit, so you have to use the bigger one breadboard. Okay, so this is the breadboard. You have to see here. Okay, in this breadboard you have to see like when we have to click here A, B, C, D, E. These are attached. Okay, you have to see here it's attached here A, B, C, D, E, and like this we have to attach this F, G, H, I, J also. Okay, it's attached. Okay, already. And there is a plus sign and there is a minus sign here, and there is a plus sign and there is a minus sign here. Okay, so plus sign is like it's a positive supply. Okay, positive supply circuit, it's connected. Okay, and this is the negative supply. It's also connected here. Okay, both the side you have to see the plus and minus sign. This is the positive terminal and this is the negative terminal. Okay, so this is the first component. Next component what we have to need, this is called LED. Okay, so LED is light emitting diode. Okay, so in the LED you have to see these two components, the two terminals. Okay, so this is the two terminal device also. Okay, LED, light emitting diode. So here is the anode and this is the cathode. Okay, so what is anode and cathode? Anode is positively charged. Okay, and this is cathode. Cathode is negatively. Okay, negative terminal. This is the anode. Anode is the positive terminal and cathode is the negative terminal. Okay, if you are go to your ATL lab, you have to see in the LED one long leg and one terminal, and one second one is very small. Okay, so the bigger one is anode, like positive, and the smaller pin is cathode, like negative terminal. Okay, next thing we have to take the resistor. I already told you resistor like reduce the flow of current. Okay, so this is called resistor. It's also a two terminal passive device. Okay, I told you active and passive devices, so this is the passive device also. Okay, and this is also a passive device. Next thing we have to take the push button also. Push button. Okay, it's a normal switch. Okay, normal push button. We have to click here and put this on off. Okay. Next thing we have to use the 9-volt battery. Okay, so this is the 9-volt battery. You have to see here the red one and the negative, the black one. So red one is positive and the black one is negative. Okay, so this is the positive and negative. We have to find here. So this is these are the components we have to use in today's circuitry. Okay, so this is very easy to perform any like prototype circuit using this Tinkercad. Okay, we have to collect all the components and then we have to use the breadboard for making the circuit and combining the circuits. Okay, so first thing what we have to do, first thing we have to take this push button and we have to rotate this one. Okay, and put here. Okay, you have to see, you have to take one. Okay, yeah, first thing, if you want to make as a hardware also, so you have to go to your ATL lab, okay, and find out this component. Okay, like you have to take first breadboard, this push button, this LED, this resistor, and this 9-volt battery. Okay, so what we have to do, first thing we have to take this push button, okay, and put here. Okay, and after that we have to take our LED and we have to rotate this LED also. Okay, and connect here. Okay, like this. Okay, in the series we have to connect the push button and the LED. Okay, next thing what we have to do, we have to connect anode of the LED with any terminal of the push button. Okay, like we have to attach the anode with the push button. Okay, if you want to make the wire, so anywhere you have to click, okay, and find out the wire. Okay, so we have to connect the anode of this LED with the leg of this push button. Okay, next thing what we have to do, we have to connect our resistor. Okay, so we have to connect the resistor in this right here, the terminal, the cathode. Okay, we have to attach the resistor with the cathode. Okay, if you want to change the color of the LED, you have to change the color also. Okay, like you have to take green color LED, you have to take the yellow color LED, you have to take orange color, you have to take blue color also, you have to take red color also, and you have to take white color also. Okay, for now we have to take the yellow color LED. Okay, so all the LEDs are same, 2 terminal devices. Okay, so what we have done, okay, we have to attach our LED anode with the anode with push button. Okay, and we have to attach the cathode with resistor. Okay, next thing what we have to do, we have to power up this circuit. Okay, so provide the power, we have to use the battery. Okay, so first thing what we have to do, we have to attach the positive with the positive terminal. Okay, and we have to attach the negative to the negative terminal. Okay, this is connected, this like this is the positive terminal and this is the negative terminal now. Okay, now we have to like power up this circuit. Okay, so what we have to do, this is the power provided to this breadboard here. Okay, and then what we have to do, we have to attach the power source with the circuit. Okay, so what we have to do, so when we have to attach this positive terminal with the push button. Okay, and we have to take attach the negative point to the other side, other terminal of the resistor. Okay, so this is the circuit. Okay, first thing what we have to do, we have to take one breadboard. Okay, and on this breadboard we have to mount this push button. Okay, and after that we have to take this LED. Okay, and we have to connect the anode with this push button. Okay, and cathode with this resistor. Okay, and the second terminal of the resistor is connected with the negative point. Okay, and the another terminal of the push button we have to connect it with the positive supply. Okay, after this what we have to do, we want to check this circuit. Okay, is this correct or not? So what we have to do, we have to click on the start simulation. Okay, and you have to click on this push button. You have to find here LED will blinking. You have to see LED is blinking here. Okay, you have to use another color also. You have to use the red one. You have to click on this push button. You have to see here LED is blinking. Okay, so this is the very basic circuit. Okay, like we have to use all the components. So I think everyone, you have to aware about the Tinkercad. Okay, using Tinkercad, you have to make this circuit on this platform. Okay, after that, you have to find all the components in your lab. Okay, like you have to collect breadboard, LED, switch, push button, resistor, and 9-volt battery. Okay, so you have to find out this. But we have to take the resistor of 1 kilo ohm. Okay, we have to take the 10 like 100 ohm also. We have to take 1 kilo ohm resistor also. Okay, so we have to attach the resistor and battery. We have to attach LED, and we have to attach the push button. Okay, all these things we have to attach on this breadboard. Okay, if you want to make this like permanent circuit, so in the place of this breadboard, we have to use the printed circuit board PCB. I told you already. We have to use the PCB, and we have to mount all these components on that PCB. Okay, and then we have to with the help of solder, we have to mount okay, that component, and we have to make the circuit. Okay, so this is called Tinkercad. Okay, so I think this is the task for everyone. You have to use today. You have to log in with your Tinkercad. Okay, using your Gmail ID or your parents' Gmail ID. Okay, and then what we have to do, you have to make this circuit. Okay, and if you have ATL lab, okay, so go to the ATL lab and find out all the components, and you have to see all the things. Okay, like I told you, like you have to take the LED, and you have to find out the where is the anode, where is the cathode. Okay, and you have to see the resistor also. You have to find out the 9-volt battery. You have to attach all the things and make the circuit. If you are able to record the video or make the video for making all, like doing all the things in your lab, it's better for you. Okay, you have to send the video, or you have to record your own video and send it to in the WhatsApp group also, or you have to send me the personal chat also. Okay, so this is the thing. Okay, so we have to learn here. Okay, today, like first thing you have to learn industry revolution. Okay, tinkering revolution. Okay, and in the revolution, we have to develop the industry, and we have to develop the production, like we have to raise the mass production and all the things. Okay, and we have, after that, we have to see the basic electronics things. Okay, we have to use from the electronics, and we have to see the active components also. We have to use the passive components also. Okay, after that, we have to see this tinkering platform. Okay, tinkering means like we have to develop something, like we have to do anything it yourself. Okay, do it yourself. It's DIY. Okay, like we have to use some DIY kits in your lab. Okay, also, so DIY is a very good thing. Using this DIY, we have to develop any circuitry. We have to develop, like we have to make the robots. We have to make some components for using in your real life. Okay, so we have to develop anything using DIY kits. Okay, so this is also DIY kits. Do it yourself. You have to collect all the components and make the circuitry. Okay. Okay, anyone, if you have any doubt, you can ask me here. I have to just wait. In the chat. If you have any doubt, you have to put the query in the chat box. If you have any doubt, anyone, you can ask me anything. Okay, related to this topic. Okay, tell me. You have to put your query in the chat box. Anyone? Okay, okay, very good, very good. All the concepts are clear. That's good. That's nice. Anyone else? You have any doubt in the revolution and in the basic electronics things? Okay, tell me here. Okay, so we have to wait for some time and then we start the next thing. Okay, just wait, everyone. If you have any doubt, you can put in the chat box. Okay, and this is the Tinkercad link. Okay, you have to open this tinkercad.com and you have to log in with your Gmail ID. Okay, and you have to make the circuit. Okay, you have to make the circuit in your ATL lab also. Like you have to find out all the components. Okay, and then make the circuit. Okay. Approx 11 or 12 done. Okay, just wait for 5 minutes, then we'll start. Okay.
Hi everyone, good morning. I hope we are completed all basic electronic components about and circuit designing also. And so some more we need to discuss about again Tinkercad software.
No, it's done fine. Okay, you have to carry on the next thing. Okay.
Can I continue this or?
Yes, you have to continue.
Okay, guys. Today we learn about basic electronics and how we can use. Most of the we have 80 labs. In that 80 labs, different components are there. But if you want to build any project, like if you want to do new projects, we need to select and we need to buy or we need to take components, all components, and then we can do projects. But that is difficult. Each and every components if you buy, it's difficult, and sometimes we don't know how to use the components also. And if you use components without knowing about components and circuiting designing, it will damage, or sometimes it's harmful to us. That's why first of all we need to practice in online. This is the best option and the best online website and application. We can practice here virtually, and our projects, whatever we have ideas, whatever we have thoughts, that ideas we can implement here and do prototypes and do your projects here easily. And real time we can do this according to the whatever we are built, circuits here. We can implement this real time. Okay. First of all, already Akhilesh sir told, basic electronics, what is LED, resistor, switch, how we can use batteries and breadboards. Just again, some more components we need to take and test it again. Okay, is it right? This is the online platform. Okay, whenever you want to do projects, just change your, give the project name, any project name, like LED, your project name. First of all, we need to enter our project name. See here, upside and left side here, LED, our project name is LED. And first of all, how we can start? Just go to the Google website and type there tinkercad.com. It opens like this. Okay. In this, we need to enter our Gmail account. It creates our account permanently. Whatever we are doing in this application, it automatically saves in online. Okay. Here we have 3D designing. In this software, we can do 3D designing, 3D modeling, and virtual circuit designing like this. I have done, so many projects like this. And coding also we have, we can do here. And if you want lessons, you can also follow these lessons, basic lessons like this. If you want to, you can follow these lessons. Otherwise, if you know about doing projects, you can just follow directly, open that. I will show that. If you want to open new, just click on that Tinkercad logo. On that click on that Tinkercad logo, it will opens like this. Now create new circuit. Click on that, create new circuit. It opens like this. Okay. Now we are directly search in such box. If you want to breadboard or LEDs, whatever you want, just type here. And it will appear like this, lots of components. Just select what we want. Just select the component, breadboard. Drag it here. No, I select 2 breadboards. Just delete one. Delete option here. Delete one. And either already Lesser told, mirror rotation. If you want to rotate this, you can rotate. And if you want to delete, you can delete, and undo and redo options. And notes tool. If you want to make any note on that components, you can select this option. And this is the wire coloring. And here, wire types, normal, hookup, and alligators, automatic, different types of things. First of all, we do one small project with LED and battery. Next, just small project like that, LED blinking that we are doing. Just select LEDs, drag it, keep on that breadboard. I hope you all know about LED. LED has 2 terminals, and positive and 1 negative, means cathode and anode. There's a long one is anode, and the short one is cathode. Just keep on that LED on the breadboard, Now, if you want to change, color of the LED, you can change color. So whatever you want, which color you want, you can change the color according to that. No wonder red one. Okay. Then after battery, 15 or 9 volts, whatever you want. Click on the battery. Type here battery. You can see here different 3 volts battery cell and 9 volts battery and 1.5 volts. According to our requirement, you can select the components as batteries. No, I selected 9 volt battery. Now on breadboard, I hope you all know about breadboards. On breadboard, upside these row is these are negative. Totally, this line is internally connected, and this one also internally. These are different. These are not connected internally. This minus and plus. Individually, these are internally connected. These are all volts, and this one also. And come to this these 2 lines here. These are connected like this vertically, from this J to F, and these points like this, and this one is same, and this one lost and first one is same. Okay, these are internally connected connections. Just I'm connecting LED, one LED. Battery positive to here, or just wait. See here, battery negative to breadboard negative, and battery positive to here positive line. Then how we can connect on one, how we can complete the circuit. Positive terminal of LED to battery positive. We are connected here. Here. Sorry. LED positive to battery positive. Then after LED negative to battery negative. Like this. Now we are completed circuit. Complete circuit. Just operate it now. Is it working or not? Test it. Click on the here start stimulation. Click on the option start stimulation. See. So now LED is glowing. Is I'm bursting, no? High voltage. We are supplied high voltage. That's why it's glowing high, no? So here current through the LED is 915 milliamps. Well, absolute maximum is 20 milliamps. It's required only 20 milliamps, but we are applied 9 volts battery. That's why its brightness is high. So if you want to reduce that flow of current, what we can use? How we can control that flow of current? How we can reduce that brightness of LED? Anyone? Okay, if you want to change, you can change color of LED. Means wires, wiring colors. It's like this. Okay. Okay, we can reduce the width. I hope you all know about resistors. With the help of resistors, we can control the flow. Just whatever you want, you can search here components. You can select that components. Okay, just select here, drag it. Where we can connect. LED is a 2-terminal device. One is a negative one, another is positive. As a battery also 2 terminals, positive and negative. But come to this resistor, is that here we can't find terminals, 2 terminals. It is a single terminal. We can use a resistor in between positive terminal of battery and LED. See, yes. Now we can connect resistor to battery positive. Now test it. See, now LED is glowing, properly. This is the complete circuit. A resistor is a resist the flow of electrons. If you want to know here, we can change resistor resistance value. Here, pico ohms, nano ohms, micro ohms, milli ohms, kilo ohms, mega ohms, giga ohms, like that. Whatever we want, in how much we want resistance, we can take that resistance value here. Okay, if you want 100 kilo ohms or 1000 kilo ohms, 1 kilo ohm, like that, we can change the resistance value. Okay. Now, can we take another device? We can take. I hope you know about buzzer, capacitor. These all, capacitor is it is also one terminal device. It stores the energy. It is like a battery. If you all know about battery, it stores the energy for some time. Our digital watches, some small devices we are using, big also we can use, but these are stores energy for some time, like battery, capacitor. And come to that, we can operate different components. Test the motor, take the motor, and also try it. Whatever you want, you can do here. Select the components and drag it here, and connect the connections. Complete the circuit. You can operate it. Okay. Just I'm connecting battery negative to the motor negative, and otherwise we can mount on that. Keep the motor on the breadboard. It's better, like this. Now we can connect battery positive to motor positive to battery positive. Okay. Next. Or wish. Motor negative to battery negative. Just test it. Start the stimulation. See here, battery is running, like that. Different components you can test here. Or we can, and sensors are there, and motors, sensors, and Arduino boards are there, microcontrollers. You can use more here, buzzers also. This is a buzzer. Connect this, positive terminal and a negative terminal. Just here, if you don't know, positive and negative, which is the positive and which is negative, you can keep your cursor on that terminals. You can get it negative and positive, like that. See, buzzer negative to battery negative, and buzzer positive to battery positive. Okay, now test it. Otherwise, if you want, change the color of wires. Now see, buzzer also working, and motor is also running, and LED also blinking. Okay, I hope you all are getting. If you have any doubt regarding these all components, how we can use, and we can connect that connection, we can build circuit. If you have any doubt, you can ask and you can raise your hand. Okay, guys. I hope is it clear my voice? Of you? Okay. So I will show that my. I have done these projects. You can also make different projects in our Tinkercad software. and it saves automatically. No need to save. We are just do the project whatever you want, and you can check it. Okay. Just I'm opening. Wait. See here, I have done one project like the one sensor I use here, sensor, photo resistor, means Ldr sensor, light dependent sensor. If you all know about street lights, how that street lights are operating, like whenever that sun rises, in the morning sessions, street lights off automatically. Whenever in a night time, it's automatically switch on the lights. It depends on the light. Here also we can do, and we can test here. This is a Ldr resistor, the sensor. It depends on the light. It detects light, and according to the light, it operates the LED lights. Just assume this LED is our street light. Okay. See here, whenever my cursor moves to this, sun side, means the here is opposite there. I kept opposite. See, in dark time, it's I have done opposite to that. Whenever light is high, LED is high. Whenever light is low, LED is low. How we can connect like that means LED connected to digital pins. Whenever we are talking about microcontroller, then I will again explain about microcontroller and sensors. Okay. First of all, we need to learn about, and we need to discuss about sensors and ICs. Okay. Just see. Come to that topic. Before we should discuss about sensors and integrated circuits, then we can work on that sensors. What are the sensors? How we can use sensors and motors and Arduino microcontroller. Okay, just see here. Our next topic is agenda is introduction to integrated circuits and sensors. And first of all, introduction to integrated circuits. Then after, introduction to sensors and history of sensors, and then we can discuss about types of sensors and principles and sensors characteristics. And we can have small activities on that sensors. And okay, we go through this. I hope you all know about ICs. In each and every component and means electric device has ICs, integrated circuits. These all ICs are these are heart and brain of that circuits, means that components. Number of components mounted on these ICs. See here in the right side in this picture, lots of components are mounted on this chip, small chip, on that resistors, transistors, capacitors, whatever, all things according to our project. How we want to build our project, how we can operate that project. According to that, we can build our ICs. So here these are ICs. See here, these are small chips. They different types of ICs. See, these are we can see on microcontroller. If I think you all know about a microcontroller, Arduino, and that we can see microcontrollers and ICs, different ICs. These are different types of ICs. See, and come to that characteristics, classification ICs. How we can classify ICs means here different types are there. Small scale ICs, integrated circuits. Means small scale means in this we are means in these small chips ICs, 10 up to 10 transistors are using in these small scale ICs. And come to the medium scale means in this in between 100 to 10 to 100 transistors are using in these medium scale ICs. And come to the large scale. In that large scale ICs, we are using 100 to 1000 transistors. Number of transistor depends on that number of transistors, how many transistors we are using, like that we are classifying them. And very large scale, in that very large scale we are using 1000 to 10,000 transistors. And super large scale means in this 10,000 to 1 lakh, like this. And ultra large scale means 1 million, up to more than 1 million transistors we are using in these large scale transistors. Okay, these are small about only IC. What is the IC? How we can use and where we can use. Means each and every electronic components, we are using these ICs. This is the main heart and brain of the components. Okay, see, we can see here different gates, logic gates, OP amps, and triple pi timers, voltage regulators. We can see in that motor controllers and microcontrollers, microprocessors. In these all components we can see these ICs. Okay, and after the ICs, we are going to discuss about sensors. Guys, any doubt on regarding this ICs? Guys, these are small chips. Okay, sensors. Anyone knows about sensors, guys? Children? Sensors. I hope you all know about sensor guns, senses. We have 5 senses. Same like here, we are using sensors. Just think about sensor guns. We are using. We can listen. We can feel. Means temperature, how much weather conditions, how much temperature is there, like that, and we can see and we can observe through eyes. These all what is happening in our surroundings we can get easily, with help of our sensor guns. Like that, we are using here different sensors for robots or automatic operating devices. First of all, what is the sensor actually? Sensor is a device. It can observe and it can collect the information around surrounding itself, in this surrounding or in this environment, and takes that information and gives that information to other electronic devices, means microcontroller, like our brain. Just see, any mosquito or fly, just think of that, sat on our leg or eye, means, and what we can do, immediately we can beat it, sir, no, means our skin will sense something is say sat on our hand or leg. It gives that our skin will sense and gives that information to our brain. Brain will react and gives that information to other hand. Then we can smash it. Okay? We can beat it. Like that. Here sensors gathers the information and gives that information to controllers, microcontrollers or whatever controllers. These are sensors. See here different sensors: humidity sensor, flex sensor, and touch sensor, solar cell sensor, and different types are there. Ultrasonic sensor, and gas sensor, PIR sensor, and soil moisture sensor, alcohol sensor. Lots of sensors are there. Okay, let's one by one we can discuss about sensors. Okay, first of all, see. When these sensors started by using sensors you are using at 2005, it started to in the first time you are started using sensors in 2005. Then after 2006 and different sensors are came, and still we are different sensors, and presently we are using different sensors. Now presently, what is the actual sensor? Sensor is a physical and electronic device that can quantify a physical change and converts it to signals. Yes or no? It gathers the information around surrounding it. That information it's sends to the microcontroller. Means it converts that information to signals. That is a sensor. We can see in IoT different in automatic home automation like that, and different. In our mobiles also we can see whenever we are calling or we are talking in that mobile, with other persons, and the screen light automatically switch off. Why? There is a IR sensor. It detects, near to the screen, it switch off the light, screen light. Same in our TV remotes also we can use IR sensors. In the TV remote also we can observe that IR sensors. Whenever we want to change that channels, we are just focusing our remote to the TV and we are changing the channels. Okay, and different components in already exist. So many sensors are used in our mobiles. Also, we are using different sensors. Means touch sensors. We will discuss one by one. Okay. See, first in the 90s, early 2000, first sensor, the sensors used in industries. First used in that industry, factories, means a weight measuring and temperature measuring purpose and motion sensors. These are all used in that industries for their applications, means their working purpose. Okay, in the late 2000th century, first used in the mobiles and iPhone and Android phones. In the late 2000 only, the sensors are used in iPhones and Android phones. See here, the first iPhone came preloaded with these sensors, and like that first sensors, which sensors we are using in the 2000 means accelerometer sensor and a proximity sensor and ambient light sensor. These three sensors first used in the 2000. Today, we are using lots of sensors, temperature and automatically, in our mobiles, whenever we are observing in laptop or mobile, some sensors are there, humidity and temperature sensor. It automatically detects our weather conditions and gives that information on our mobile screens and laptop screens. This much 20 degrees centigrade, 34 centigrade, like that. That information we can see our mobiles and laptops. Okay, like that, different sensors we are using. See, temperature and position, chemistry, pressure and force, load and flow and level. This purpose we are using different sensors. Okay. See here, types of sensors. Different types of sensors. Color sensor, the gas sensor, Ldr. I already in the Tinkercad we done one project, means just showed Ldr sensor, ultrasonic sensor, this one, and IR receiver, soil moisture sensor. We can do with the help of these soil moisture sensor, smart farming. Number of we can do any projects, but something. Gyroscope, photo resistor, and humidity sensor, touch sensor, IR sensor, ultrasonic sensor, rain sensor. Lots of sensors are there. First of all, we need to know about these components. Then only we can do projects, different projects. We can get different ideas. Whenever we are knowing about these all components, we can get ideas easily and we can build projects easily. Okay. Come to the first sensor, temperature sensor. In that name only we can find that what is the sensor, what is the working of this sensor. The temperature sensor means it detects us temperature levels in our weather and gives that information to us. See, this is the most and most popular sensor. In all devices we are using these sensors. It measures the temperature. Okay, there are different types of sensors, the temperature sensors, like how we can differentiate these sensors, like LM35 ICs. According to the IC, we can differentiate these sensors. Thermistors, thermocouples, resistive temperature devices. These are different types of temperature sensors. See here, the LM35 temperatures IC. This one is a thermistor. And come to that next sensor, proximity sensor. Guys, if you have any doubt, just ask. No. See, is it visible, guys? Presently, I am in a temperature sensor. Is it clear and is it visible to my screen is visible? Just confirm anyone. Presently, I am playing that temperature sensor. Guys. Okay. Sorry, guys. I thought my screen is visible to all, but it's a mistake. Just see, we discussed about these ICs. ICs. These are already we discussed about these, and different ICs. Means is a small scale, small chips. These are ICs, are small ICs like microcontrollers. And that microcontrollers we can see in each and every electronic devices. We can see these ICs. Okay. Just, you know, any damaged or any component, if you find, you know, just open it, you can see components. Okay, just, you know, we're talking about sensors. The sensor is the device, it can sense its surroundings and gives that information to microcontroller, any other electronic components, like our eyes, like our skin and ears, like that. These sensors works like our sensor guns, like that. Okay, already we discussed about this. Just we are going to types of sensors. You know, we already seen these are different types of sensors. Okay, rain sensor, PR sensor, you can see here. Okay, if you are whenever you went going to our AT lab, you know, you can see there, you can take the sensor, different sensors, and you can see, you know, different sensors. You can find these all sensor in our AT lab. So ultrasonic sensor and soil moisture sensor, air sensors, touch sensors, different sensors are there, rain sensors. Okay, just, you know, now we are learning about what is that sensor, how we can use, and what is the principles involved in these sensors. Okay, these are temperature sensor also we are completed. And in this temperature name, we can find that what is the purpose of sensor. No? Temperature sensor means it senses the temperature. It measures the temperature in our weather in our surroundings. Okay, and we can difference, and we different types of sensors are there. No, LM35, DS18B20, thermistors, thermocouples, RTD means resistive temperature devices. These are types of temperature sensors. Okay, and come to that proximity sensor. Anyone knows about proximity sensor, guys? Now is it audible? My voice is audible? Anyone? Guys, just confirm.
Yes, you are audible.
Okay, okay. Thank you. Okay, there's a proximity sensor is a non-contact type. So, one type, no, non-contact type and contact type sensors are there. This is a non-contact type sensor, proximity sensor. It detects the presence of objects without touching. It can detect. No, now we said IR sensor, like that. Without touching, it can detect. Like with the elbow, light, reflection of light, like, and different sensors are there. Proximity sensor can implemented using different techniques like optical, infrared rays, and lasers. Rays are using in this sensor, and ultrasonic waves are also using this proximity sensor, and magnetic field and capacitive. These all are mounted in this sensor, proximity sensor. These are multi-purpose sensor. And come to the next sensor, IR sensor. I hope everyone knows about this IR sensor. In each and every, presently we are using IR sensors, mobiles, TV remotes, and AC remotes, any devices, each and every devices we are using these IR sensors. This is a IR means infrared ray sensor, infrared sensor. It has two terminals, means one receiver and one transmitter. Transmitter emits that what IR rays, and receiver what it will do, and if it will connect that whatever reflected lights, a transmitter transmits that IR rays, and receiver receives that reflected IR rays. Then it can detect. Okay, if any object in front of it, it can detect. It based on that reflection of light. What is the principle involved in this IR sensor means reflection of light in the principle for this IR sensor. Okay, already we discussed it in that proximity sensor. In this we are using same IR sensor, means infrared rays. And come to that ultrasonic sensor. Here also this one also non-contact type. IR sensor also non-contact type. Without touching, it can detect objects. Okay, proximity sensor also non-contact type, and IR sensor non-contact type, and ultrasonic sensor also non-contact type. But in the principles is different. In the whenever talking about IR sensor, it depends on the reflection of light. Come to the ultrasonic sensor means it depends also reflection of sound waves. It depends on the reflection of sound waves. It emits the sound waves. Whether IR sensor, it emits the IR rays. With the help of IR rays, this IR sensor detects that object, and this ultrasonic sensor detects the objects like with the help of sound waves. These are non-conductive, and with the help of this IR ultrasonic sensor, we can measure distance of that any objects, or we can measure velocity of any moving objects. Okay, these are sensors. And come to the LDR. Already we discussed about this LDR. In street lights we are using. I hope you all know about street lights, automatic street lights. And that street lights, we are using. We can use this LDR sensor. We can call it photo sensor or light sensors. We can call it another name, photo sensors like that. And how that it works like that. Whenever lights fall on that sensor, it detects, and it sensitivity or intensity is decreasing. Whenever light is its intensity is decreasing. Like that. That the principle is involved in this sensor. So here, when the intensity of light increases, its resistance decreases. Vice versa. Whenever sun comes morning, lights switch off, and in the evening time, lights getting switch on with the help of these LDR sensors. Okay, and come to the smoke and gas sensors. In the name only, we can find that smoke sensor means it detects the smoke, and gas also. It detects the gas, leakages, gases, leakage of gases like that LPG and whatever the different gases, it can detect and help us to alert. Almost all offices, official offices means in industries and and hospitals, we can use these sensors for protecting us. Whenever fire attacks happens, and the time these sensors detects what is happening there, detect the smoke, leakage of gases, and gives that information to us, and we can alert that and protect us and our property also. Okay, so here, and these sensors can detect LPG gases and propane gases, butane, methane. These all gases can detect by these sensors. Okay, and come to the next sensor. This is the alcohol sensor. I hope you all know about this alcohol sensor. It detects the alcohol level. Means in our traffic police, in that department, police department are using these sensors in that and drunk and drive test. That the equipment in that equipment, these sensors are used. In the breathalyzers and catch the drunk and drive persons. They in the departments. These sensors are using. And come to the next sensor, touch sensor. I hope all of you know about this touch sensor. We can see these sensors in our mobiles. Totally our screen is a touch sensor, touch screen, and some laptops are touch screen laptops are there, and in our laptop, trackpads are there. We can, in the trackpads we are using the touch sensors. So, most of that now we don't know, but we are using our daily life. This is our internal part of our daily life. In mobiles and laptops, tablets also, we are in the tablets also we are using these touch sensors. Okay, just a brief idea what are the components, what is it, these all look like, and how we can find that information. Just basic information you are getting here, and we can do these projects in Tinkercad software also. We can do in our ATL lab. Okay, brief idea of these sensors and devices. And come to this humidity sensor. Humidity means it's also same. It detects humidity level in our weather and in our surroundings in our environment, and temperature levels also it detects, as well as temperature and humidity. It detects two humidity and temperature levels, and that gives that information to us. Like in our laptop, we can see what is the humidity level and temperature level on the screens, and our mobiles also we can see on the temperature level. It detects that weather conditions and gives that information to us. So easily we can find this with help of these sensors. Okay, and come to that, this tilt sensor. Tilt sensors are one of the simplest and inexpensive sensors out of there. Previously, tilt sensors are made of mercury. In the previous means in olden days, they were used mercury for a tilting purpose. Presently, we are using roller balls. Instead of mercury, we are using roller balls. Means with the help of tilt sensor, we can find that angles, different angles, means at what angle with the equipment or device we can tilt or move. Like that we can use this tilt sensor. Means whenever we want to rotate our screen in our mobile, means like that video games, whenever we are playing video games, we want to rotate our screen and one mode to another mode. Like that purpose, different purpose we are using the sensors. And come to the next, sensor characteristics. What are the characteristics for sensors? We know about that sensitivity of sensors and drift value of sensors and resolution. Sensors resolution and linearity. What is the repeatability and reproducibility? Sensitive we can measure in decibels. Ultrasonic sensors, sound waves. How much that generally how much we can listen. Sensitivity of general sensitivity of is 89 decibels. We can listen up to this 89 decibels. And drift is that reading, specific reading of that sensor. It means full scale drift and small, zero drift. Actually what is that drift? Sensor is kept at that value for a prolonged period of time. The zero drift refers to the change in sensor output if the input is kept steady at a level that it's zero reading. Similarly, the full scale drift is that drift if the input is maintained as a value which is originally yields a full scale deflection. We can see different characteristics of the sensors. Linearity is determined by the calibration curve. The static calibration curve plots the output amplitude versus that input amplitude under the static conditions. Its degree of resemblance to the straight line describes the linearity. Okay, these are characteristics of sensors. Okay, and how that sensors continue to evolve. As human beings started using technology for a better life. Why we are using these sensors means our better life purpose. Easy to do our projects, easy to do our work. Like that purpose we are using these sensors and technology. And what is our needs? How we can do our works easily? How we can achieve our goals easily? How we can protect us? Simply, for that purpose, we are using the sensors and technology. And industrial sensors collect raw data in the manufacturing. In the industries, whenever we are talking about industries, in that industries, so lots of work processes are there. Some in that purpose, some various data we need to collect. How many equipments are there, how many manufacturing have done there, and what is the temperature there. For each and every measurement purpose, we can use that sensors in industries and factories. Okay. Sensors come in many different types of collect different various varieties of data, including motion, position, and environmental, machine to machine and human to machine interaction purpose, and current, infrared, and acoustic, and ultrasonic sensors. These all are sensors. Position sensors are there. Machine to machine understanding purpose, and human to machine understanding purpose. We can use sensors. Okay. This is about sensors and integrated circuits. We completed. If you have any doubt, just ask me, guys. Regarding these sensors, if you have any doubt regarding any sensor, you can ask, and ICs also. And if you have doubts in Tinkercad also, you can ask. Guys, anyone? Just we are completed basic. What industrial revolution? What is that industrial revolution? At what level we are at? What is happening in the previous? What is happening presently in that society? That all things we learn in morning session, and also we discussed about basic electronics. What are the types of basic electronics, and how we can use basic electronics? Without knowing basic electronics, electronics, these concepts, without knowing this, we can't use. If you use, sometimes components will damage. Sometimes we get injured. So that's why we need to know about, before doing projects, we need to know about project components and principles. Then we can do easily. That purpose, this virtual circuit software is, Tinkercad software. In this software, we can practice a lot of projects, and at our home, with the help of mobiles and laptops also, we can use this Tinkercad software and do a number of projects. Whenever it's done, successfully, we can do real time. Just coding also we are done and doing here. Just upload this code to real time boards, means microcontroller or any. Just send the information to that, and it works automatically. We can make it easy. Guys, anyone, if you have any doubts, just ask me regarding these today's basic electronics or Tinkercad or sensors, ICs. Children. Children, if you have any doubt, just raise your hands or ask. Okay. Chat box also you can. Is it clear about sensors? If it's not, I will tell again. Sensors and ICs. Basic electronics also. Children, is it audible? Guys, everyone?
Yes, it's audible.
Is it my screen is visible?
Yes, screen is visible.
Okay. Sensors completed. Let's see. Let's wait. I will show that how we can code for that sensors and how we can operate the sensors with the LEDs and microcontroller. I hope you all know about microcontrollers. So guys, here we are using Ldr sensor with one LED and microcontroller.
Sanjeevlo, I think screen is again stuck.
It's okay. Wait, I'm sharing again. Guys, see here, is it visible? My screen is visible, everyone? Guys, anyone confirm it? Presently, I am in Tinkercad software. Is it
Yes,
visible?
yes, yes.
It's visible.
Yes, it's visible. Yes.
So we are completed basic electronics. Also, we are connected different components, means LED, resistor, capacitor. These all we are taken, means we are doing manually. We done manually, but now we can do coding. How we can do coding? Okay, I will show you. So first of all, what we need for doing projects? First, we need breadboard for safe connection for me. Let's select breadboard. You all know about breadboard. No, why we are using breadboard? Breadboard for safe connection purpose. If you take if you want to take number of components to operate, it's difficult to connect directly. For that purpose, we are using these breadboards to make the connections easily in the proper way. Okay. Just select breadboard. Then what we need? LEDs. We are blinking LED. Just presently what I am doing just I am blinking the LEDs. Basic, giving the code to LEDs. Blink the LED. I'm selecting LED, just one LED. Then after we can take different components. Okay. I think you all know about how we can change the color of the LED. Like select whenever you want to select change the color, just select the component and you can change it. Okay. Okay. Now next, what we need? Microcontroller. Arduino. If you want any components like just type here and you can get it. Select that microcontroller, means Arduino. I hope you all know about this. This is that like our brain. It controls the total device and total our project. Like our brain. Our brains controls our total body parts. Like that it controls. It is an open source platform. Microcontroller is an open source platform. We can do number of projects with the help of this Arduino. See, externally we can connect the connections different. In this Arduino, different ports are there. These are digital pins total. Just remember, we can discuss again, okay, about microcontrollers. These are, these are power pins. These are analog pins, and this port is, we can send or we can dump the code through this port, and we can charge also. And this is a charge point, means power port. Just remember these basic parts. We can discuss again each and every component. Okay. Just presently we are doing one project with the coding, LED blinking. So we can change our project name also here. LED blinking. Okay. Now change my project name, LED blinking. Okay. Now how we can connect? Just connect that LED. See, in that Arduino, we have positive pins and negative means positive pins means power pins here 5 volts, 3.3 volts, and ground pins are there. And means if you want to operate, if you want to take power from this Arduino, we can take from these points. Or if you want to code, we can take the digital pins. Just I'm connecting LED positive terminal to any digital pins. Okay. Then after LED negative to ground pin. See. Presently, I connected this connection. See, next we need to do code. Here, click on the code option. You can get like this. This default is always it's here. Just delete this default code, and actually we are using here Tinkercad software block coding. Blocks, different blocks are there. Output and input, notation, control, maths, variables, different blocks are there. Just here we need to select the blocks and drag it here workplace or a coding place, and you can do coding. Just select what we are doing presently. We are doing LED blinking. Just take LED, set pin, which pin we are selected? 7th pin. See, LED positive where we are connected at 7th pin. Just change that pin to 7th. I means on. Just wait, guys. Sorry, guys. Just presently what we are doing, blink the LED with the code. We are selected set pin output pins. What is the is it LED is output device or input device? Is it output device? Why it blinks that it do that what light means it gives the light outside. That's why we are calling LED is output device. Here setting pin, output pin 7th. Here is connected here 7th pin. I means on. In this code, I means on or 1 0 1. 0 1 means 1 is for on, 0 for off. Now we need time. So I means on time, up to how much time it's on position. So I kept 1 second for on position. Then after, if you want to blink LED, we need to give the code for on and off. Just next, we are taking set pin 7th low. Low means off up to 1 second. You can see this is the code, simple code. This is the black coding, is a simple. Anyone can learn easily. And if you want to operate manually, means real time, just send this code to your boards. Here send option is there. Just click on that option, you can get the code. Theoretical also we can get. First of all, we need to know is it working or not. Okay, test it. Start the stimulation. See, LED is blinking, LED is blinking. Means this is a simple code. You can see this also text code also we can see here. Text code also, block code and text code. Like, most of the students will know about text coding. This in our Arduino software we can do this text coding. In this block coding we are taken only 4 blocks. Simple. Here automatically it's taken like coding, text coding. This simple. If you can, if you want to do text coding also, you can do here, or otherwise you can select block coding. Okay, the simple coding. Okay, okay, we done on LED blinking. Here, see here, we are applied. Here we need to take resistors. Okay, why? Because of we are supplying more power to the LED. Take the resistor and if you want, you can change that what color of that wires. See, now just one LED only be done project. If you want to take a number of LEDs, 3-4 LEDs, how we can do code for that LEDs? See, now see, we can do that. Take the LED again. I'm doing 3 LED blinking. Now again, just say take that LED and keep here. You can also change the color of the LED, yellow or orange or blue, any color. I'm taking yellow color. Okay. Now again, one more LED I'm taking. Just see and change the color blue. 3 LEDs are taken. I've taken 3 LEDs and resistors also. I'm taking 3. I'm connecting the resistor to LED positive and one more resistor for second LED positive. Okay, now just connect these all negative terminal to ground pins. I'm taking this is a common. This is a common line. I made this total line is a negative. Actually, here I made this total line is negative for simple connection purpose. All LEDs negative connected to this negative means ground pin. See, second LED connected to this ground pin and this third LED connected here ground. And next positive terminal, we need to connect this positive terminal for here resistor to digital pins. Here any digital pins you can take 5 or 4 or I'm taking fourth pin. Second LED connected at 4th pin and third LED positive to second pin. Just I connected 3 LEDs in the manner. Now we need to code where the circuit designing completed. See, negative to LED negative and positive positive of LED to positive terminal to LED of positive terminal to digital pins, and next positive terminal of this second LED to digital pins, and this positive terminal of third LED positive terminal to digital pins, and all 3 LEDs negative to ground pin. I taken here. This is a common ground. Now we are doing code. Now I want to blink 3 LEDs. What we can do? Guys, anyone? Already we are given code for 1 LED. Now two more for 2 more LEDs. We have to give the code for 2 LEDs. Remain 2 LEDs. What we can do? Anyone? Okay, I will do here. Take the set pin. Same means second pin where we are connected at 4th pin, you know. I means on. Next, take the delay time means up to 1 second, or if you want to change the time, you can change in milliseconds. It's better 500 milliseconds or 300 milliseconds, 400 milliseconds. How much you want, you can take here delay timing. Here also I'm taking 500 milliseconds. Here also. Okay, guys, just first LED completed. Second LED just I have given I on up to I on, you know, second LED I, then second LED off. Off means low. 4th, no, pin number 4th is low. Low means off. Then waiting time means up to 500 milliseconds. It's off position. It is in off position. Okay. You know, alternating blinking. I'm giving that first LED on and off. Then after second LED. Then second LED gets on and off. Then third LED. Like that, I'm giving code. If you want, you can blink at a time 3 LEDs. And you know, different manner you can operate. So just see here, and we need to do the third LED code for third LED. Select that pin, set pin. Which pin we are selected? Second pin, you know. At second, I means on. Waiting time. Here also we need to give that waiting time. If you want to change that waiting time, you can take the 1000. 5000, 3000, you know, 1000 milliseconds is equal to 1 second, you know. You can take the timing, different timings. Third LED is I, and then third LED is off. I'm making third LED is off, means second pin low. See now I have given 3 coding for 3 LEDs, 7th pin, 4th pin, 2nd pin. Completed. Just test it. Is it working or not? Guys, is it working? No, LED is blinking. No, LED, red one, yellow one, blue, red. Yes, 3 LEDs are working, you know. Yes, we don't this. This is the code for LEDs. So if you want to operate different components, you can take buzzers, motors, instead of LEDs. You can see, you know, just see here. Alternating, we are given alternating blinking. You know, if you want to blink at a time, what we can do? If you want to blink the LED, 3 LEDs at a time, where we can change the code. Guys, here see, I given no first 7th pin I, means first LED is on. Then I have given after low second LED. Here instead of here, we can take the all 3 LEDs at I position, then give that time. Then after make the 3 LEDs low at a time. Then we can blink LEDs at a time, 3 LEDs. Now see, I will show that. I am making 3 LEDs at I position. Three LEDs I position and just I'm making 3 LEDs high and 3 LEDs low. See, 7th, 4th pin, 2nd pin. These 3 pins are high up to 500 milliseconds. Then 7th pin, 2nd pin, 4th pin low, means off position. See, let's see. Is it working or not? Yes, is it working? No? It is working. See, 3 LEDs are blinking at a time. 3 LEDs are switch off. If you want, you can change the time also here. See time, just change the time. Now you can check it. I given on position is 1000 and off position is 500 milliseconds. Guys, up to this, any doubt? Blinking LED, coding.
ఏం పెట్టిందంటే మధ్యలో రెసిస్టర్స్ పెట్టిండు, మైక్రో కంట్రోలర్ పెట్టిండు, దీన్ని కనెక్ట్ చేసిండు, డిజిటల్ కనెక్షన్ చేసిన తర్వాత ఆ బల్బ్స్ వెలుగు ఓన్లీ ఎల్ఈడి బల్బ్స్ ఎట్లా వెలిగించాలనేది ఇచ్చిండు.
ఎస్, ఎవరికైనా అర్థం కాలేదంటే అడగండి.
అడగమంటుందా?
ఎల్ఈడీస్ ఎలా కనెక్ట్ చేయాలా, రెసిస్టర్ ఎలా కనెక్ట్ చేయాలా, మైక్రో కంట్రోలర్ గురించి మళ్ళీ చెప్తాను నేను. మళ్ళీ డిస్కస్ చేద్దాం. మైక్రో కంట్రోలర్ అండ్ మోటార్స్ అన్ని కాంపోనెంట్స్. జస్ట్ వాళ్ళ ఎల్ఈడీస్ బేసిక్ కాంపోనెంట్స్ ఎలా కనెక్ట్ చేయాలా నేర్చుకున్నాం. ఏమైనా డౌట్ అప్ టు దిస్ పాయింట్? ఎనీ డౌట్ యూ కెన్ ఆస్క్ అండ్ రైజ్ యువర్.
అడుగుతావా రెసిస్టర్స్ ఇక్కడ ఎంత ఎంత కెపాసిటీ?
సి చూపిస్తారండి, మనం రెసిస్టర్స్ ఎంత తీసుకున్నాం, ఎందుకు అలా అవుతుంది. సి ఇక్కడ మన హియర్ వి ఆర్ టేకెన్ 1 kilo ohm resistance. Just change here ohms. ఐఎమ్ టేకింగ్. అబ్జర్వ్ చేయండి, ఇక్కడ మనం ఇక్కడ రెసిస్టెన్స్ చేంజ్ చేస్తూ ఉంటే ఇక్కడ కలర్, మన రెసిస్టర్ యొక్క కలర్స్ కూడా చేంజ్ అవుతున్నాయి. ఫస్ట్ ఎలా ఉన్నాయి? రెడ్ కలర్, బ్లాక్ అండ్ ఆరెంజ్. నౌ 100 ohms తీసేసుకుంటున్నాను. Now also it's working. No, I will take that 100 ohms to 1 ohm. See, now see here I have taken the blue LED for resistor 1 ohm, only 1 ohm I have taken here. So here see what we are getting here. What we are getting? See, current through this LED. Stop the joint ikkada. Maximum LED calls LED requires 20 milliamps only. We are supplied more than 20 milliamps. That's why it's showing here different symbol. See, notes it's showing here note.
Sir, I have one more doubt.
Yes, you can ask.
Okay, so here we have used resistors, right? So why can't we directly connect it to the okay, so I'll take an example of value 7. Okay, positive 7, right? You can just directly connect it to 7 and then make a delay, right? Why should we use a resistor?
Okay, we can also use that. Means here, power supply is that's why it's see, let's see. We will remove that resistor and deleting. I am connecting that resistor directly. No, see. Okay, you want to change the delay. You want to give the delay for third LED. Where is third LED? Fourth, no? I am separating that fourth, last one LED. See, let's see what will happen. Fourth or second, you know. So tell me now how much we can take here. If you want to reduce
Any
the
value is fine.
okay. Any value means 2000 I'm taking here delay. 2000 milliseconds.
Okay.
Here also I'm taking 2000. See, is it changed anything?
Yes, the last light is blinking a bit slow. And
No. See,
right?
current through the LED is 53.5 milliamps.
Okay, so it resists the extra current, right?
Yes. You know, we are with the help of delay we can't resist. Means we can't reduce that power. Just we are making that blinking the LED. We can change that delay time. We are giving the here delay only. We can't reduce that current with the help of delay.
Okay. So the main function that the resistor is doing that is just resisting that extra current, right?
Yes. Resistor means it resists the flow of extra current. So you know, in our homes we are using what instead of LED means TVs, what stabilizers are we are using? Why we are using that stabilizers?
To resist extra current.
Yes. Otherwise, you know, TV will damage, you know, or blast. And mobiles also, whenever we are connecting or we are charging our mobiles, you know, we have sockets, laptop chargers and mobile chargers have sockets. The sockets will reduce that power. Otherwise, you know, our mobiles or laptops will damage. Why?
Yes, so like from what the actual voltage like 120 or 220 and it reduces it to a lower voltage.
Yes.
Right?
I know. Actually, in our homes, you know, we are using AC current, alternating current. Yes or no?
Yes, we do.
Yes, alternating current. Sometimes it's high, sometimes it's low. Whenever power comes high, our electronic devices will get damaged. That's why we are using these controlling devices, all sockets, charger sockets, and TV stabilizers, different components we are using. In these our projects also, we are using this resistor for controlling. Otherwise, our LEDs will damage. You know, if you connect directly in our IT lab, you know, LEDs, this much of power, and the LEDs will blast.
Yes, sir. Understood. Thanks a lot.
Yes, okay. It's okay. Okay, you can do a number of components also. We can take here different components also. Only LEDs only we are taken, you know. I am removing this LED. Just stop. If you want to do no operation, just stop the here. No, see here, coding, text coding, how it's visible to. If you want to see text coding like this. Output, LED is output, you know, output device, 7th pin out, 4th pin out, 2nd pin out. Here we are made, you know, two LEDs high, then two LEDs low. Then after we are given second LEDs, 2nd pin LEDs high. The same we are given high. 2 times we are given, no? Here we are given 2 times with the high only. Should give your low. Okay, just I'm taking another component, a motor or any. We're just testing different components. What we can take next? Buzzer I will take, no? See, just I'm taking this buzzer instead of third LED. Means if we are, is it code working for all the components or not? Just we are testing. Okay, so if you want to do projects, you can which is a negative. This is one positive. This is a negative, no? Where we can connect this buzzer negative to the buzzer negative, no? Here we are taking this is a common negative. Okay, then buzzer positive to, we can change the color of that buzzer. Okay, this buzzer positive to, we are already given coding, you know, second pin. You can connect here second pin.
Sir, I have a doubt, sir.
Yes.
Okay, sir, we are over here doing it using a software. So when you're doing it using hardware, we're gonna use male female wires, right? For connecting both.
Yes.
Okay, and if we connect one, we just need to connect one point to another, right? That's all.
Yes.
Okay, thank you.
Simple. You know, jumper wires in our lab we have jumper wires. We can use that wires. You know, we are taking different colors. Means our understanding purpose. Okay, these are jumper wires like. Okay, I have given the coding for 2 LEDs and 1 buzzer. Let's see. Yes or no? Is it working? Like, guys, is it audible? Buzzer sound? Yes or no? No, instead of just I removed LED and instead of LED, I kept this buzzer. The same code we can operate. If you want to give that another, you can take that your blocks and you know, you can make the code for buzzer also. Just we are connected here pins only, you know. So one more component we can take, motor, any motor, DC motor. Just take the motor and connect this also here. And we can connect motor positive to any digital pin here. If you want to make proper connection like this, you can make it. I'm taking 10th pin, guys. Motor positive to Arduino 10th pin, and the motor negative to here common ground. See, now we need to give the code for this motor also. So we are taking motor, you know, take the set pin and set pin, take the pin, which pin we have taken, 10th pin, you know, select 10th pin I. Okay. And take again set pin low, means 2 LEDs on, 1 buzzer on, and motor also on position, you know. Here low, which pin? 10th pin. See, you know, again we are taking 4 components, you know, 2 LEDs, 1 buzzer, 1 motor. Now test it. Yes, Is it working? No, it's working. No? Motor is rotating and buzzer is giving. If you want to continue and buzzer and motor, you can just here second pin what buzzer, make that buzzer I, motor also I. Now you can see here motor and buzzer is on position, LED is off position. Guys, is it clear? All of you, is it clear?
Yes, sir. It is clear.
It is a simple and it stores, it saves automatically, and no need to save you. Already LED blinking, we are given name, no? On this name, it will save. See, I will show it again. Just if you want to change, just click on that Tinkercad logo. Click on the Tinkercad logo and you will get again from first. See, it opens like this. If you want to create again new project, you can click on the create option, create new circuit. Otherwise, if you want to modify or if you want to do and whatever you've done already, just open that. Recently we done this project, LED blinking. Just click on that. You can tinker this again. Do this project. Means make some features or some differences in this project. We can make that. If you want to add, some more components, you can add that project again. See, it's opens the same, right? No. Recently we done this project. Okay, guys, just wait. Guys, today we are completed this basic components, how we can circuit, how we can design circuit designing in the Tinkercad software. And Arduino also we are using microcontroller, motors also. The basic components we are using. If you want to use sensors, different components, we can do tomorrow, okay? We can continue the session tomorrow. And designing also we can do that, different topics we have, okay? Just, 12 is a... And now next Warren sir will explain about ATL marathon. Okay, how we can register. All things sir will explain about that ATL marathon. Just listen. Okay, guys. Sir.
Yes, Sanjeev. Thank you. I'll take from here.
Okay, sir.
Yes. Hi, students. Hope everyone enjoyed the session. Everyone learned so much new things. So we will just discuss what is ATL marathon, because we are learning all these things to develop our new ideas, to bringing the ideas to life and to apply for the ATL marathon, which is actually a great event for you students. So actually I'm giving an assignment for all of you students. You have to do this assignment today once you reach the home. So before that, we will just have a glimpse of what is ATL marathon. So as you can see my screen, if you search in Google ATL marathon, the website will come, http://innovate.mygov.in, and we will be sharing this in the chat box also. You can ask your teachers for this link. If you click that link, you'll come to this website. And this program is powered by Niti Aayog and Adult Innovation Mission, and also by the Government of India. So what is ATL marathon? ATL marathon is a platform where the students can showcase their research, their ideas, their innovations, or they have implemented something, they can showcase. It's actually a great opportunity for the students to showcase their skills. So every year, ATL Marathon has different themes. Based on the themes, they will be giving you prizes, they will be giving you more exposure in state level, national level, you'll be newspapers, they will help you to bring your idea into a product. Also, if you have a good idea and it has been selected, maybe, who know, it will come up as a good product and you can start earning money from your high school. It's actually a great thing. So let's see. So for ATL Marathon, you need to create a group of 3 students. And we will discuss what are the themes. There are 4 themes. The first theme is education. The second theme is energy and transportation. The third theme is health and nutrition. And the fourth theme is social inclusion. So the participation guidelines are there. The team consisting of students from ATL or non-ATL school can submit their entries. So you need your ATL UID. The team should be consist of maximum 3 students from the class 6 to 12 and 1 ATL in charge or school teacher should be there. And you should create a video in YouTube explaining what is your product, how it helped, like that. You should do that. So that is the basics. And the last day for applying is April 10. So you have to start working now onwards. So we will discuss each day. We will be discussing what are the themes. So Today we will be discussing about the first theme, which is education. So in education, innovate to create solutions to make education and learning inclusive of resilient for all children. Those who have no access to devices or internet, mobile, laptop, TV, those that are in regions with extreme weather condition, those with no access to school, physical or virtual. So students. So there are lots of students in remote areas which have no access to device or internet like mobile, laptop or TVs. How can we help them to betterment of their education? Do you have any ideas for that? So I am giving access. Yes, if your students have any idea, you can unmute and you can tell your ideas. So let me explain some ideas first. So how about thinking a FM station? We are broadcasting an FM station continuously for each subject, each school and each sessions. So students can access that through a radio. We know radio is a cheap device. Everyone can achieve. For 100 rupees, you can buy a radio. So it is actually a cheap device. So well, how about that? An FM station, or we are transmitting it, or how about a audio device which all the sessions is recorded in it? So they can just, according to their class, they put their, because we know today the recorder devices are very cheap, like just a playback. You can put your memory card and you can play. How much it will cost for a memory card? 300 rupees. How much it costs for a audio device with earphones? It will cost around 400 to 500 rupees. So you will get a device for 600 rupees, which has all the recordings from each classes. How about that? So there are lots and lots of ideas. So we should bring some idea, we should develop it, we should showcase the idea, and we can apply for ATL Marathon. So I want you students to go to home today, spend 1 hour thinking about this. Okay, we will consider the students in Jammu and Kashmir. In Jammu and Kashmir, there will be snowfall. Students cannot come out of their house to the schools, so they will be staying in house, and the internet, laptop, mobile is not that much available there in their place because of the bad weather and network conditions. So you should think about that and consider what is the solution for them. What can I do for them? Also for the students coming from the remote areas, like there are no, because when the COVID issues came, there are lots of people suffering from this network issues, like many of your students have, as all of you know, many of students are having classes from home, you are studying from home. So there are lots and lots of issues, like the network issue are there, the internet do not have proper speed, so you cannot attend the session, or the data is over. So there are so much of issues are popping out. So how to reduce it? So just I want all your students to spend 1 hour, think about it, find some solutions, and the last day, like the 5th day, we will be discussing what is the solution and how we can change into the and apply it for the ATL marathon. Each day we will be discussing about each things. Tomorrow we'll be discussing about energy and transportation. Day after tomorrow, health and nutrition. Last day, social inclusion. So, and this is the second part, innovate to integrate soft skills, personality building and confidence, etc., technical skills, digital and 21st century skills, and a mindset of innovation in curriculum for schools or colleges to ensure students have the skill set to become successful entrepreneur or professional. So if you have an idea, like I'll suggest an idea, like if we bring an open platform for students where they can sell their ideas and make money out of it, it will promote students because you are earning. We have seen lots of young entrepreneurs who is studying in high schools, who is making lots of money. We saw it in the social medias. Why can't we can also do the same? So we have to think about it, innovate to integrate soft skills, personality building or confidence, technical skills, and a mindset of innovation in curriculum, how to bring the innovation in curriculum for school or colleges to ensure students have the skill set to become successful entrepreneur or professional. So even if you complete your school, complete your college, because lots of people are completing your college and school at the same time, and most of the people are having the same marks of them. So whenever you are going for a job, they'll be usually looking at what is the more you are having compared to others. So currently as well as the coming days, it will be a highly competitive field. So you have to build your own skills and you have to stand out of the crowd. Then only you will be identified and you are getting a better opportunities. So students, please think about it, how to make sure the skill set of the students can be developed to become a successful entrepreneur or professional. So this is the homework for today. Students, you go to your home, spend 1 hour on this, find the solution for these two content in education, and note it down and keep the note with you, and we will be discussing that at the last day of the session. Okay, students, anyone have any doubts or anything you can raise now? Every participant is unmuted. Also in YouTube live, if some students are watching, you can join the Zoom link, so you can raise your voice and you can talk any queries or doubts or anything. And it's already time's up. It's 12 o'clock, 12:04. Our session will end at 12. So we will be winding up today. And those who missed for the morning session, we have started the session from 9. Those who missed the session from 9 to 10, you can restart the session from the morning using the YouTube link. In the YouTube link, you can play from the start. So anyone can confirm everything is all right? Any students, can you unmute and confirm?
Yes, sir, everything's all right.
Okay. So students, then we are closing today's session. Meet you tomorrow at 9 o'clock sharp. Thank you. Thank you for joining Lead to Learn program.
Yes. Thank you, sir.
Thank you.
Thank you all.